Is the screen visible?
I have joined.
Okay, great. So what we were saying, we started with X, Y, and Z. That was our nucleus. And we ended up having minus X, minus Y, minus Z. What kind of operation you feel like when we were talking about 5 elements, proper axis of rotation, improper axis, identity, inversion center, plane of symmetry, what operation symbolizes where? Like, is there any operation which reflects over here? Like you can come up with anything?
Inversion center.
True. So this is nothing but your inversion center. Because there also, when we were saying, there also from the center, we have to go from opposite sides. So this is similar way if we have Z here, minus Z here. If minus X is here, positive X would be here. Y is here and minus Y would be here. So this is what we got from the XYZ. We went into completely inversion, that is minus X, minus Y, minus Z, which gives you one more conclusion that S2 operation is equals to I. This is very important. So there you do not even have to apply that C2 and sigma. You can directly put across your point that S2 is equals to inversion. Whatever the molecule or the configuration is there, you can change directly to into its inversion center. You do not have to go through all the mathematical part. So is that clear?
Yes, ma'am.
Great. So now we will move to 4th question. We still have 2 more questions left. I will just, because we are running out of time, it's 8:23. So now you need to find out the order of your falling molecules. I would like to explain all of them. I don't know how much time would persist. We will take one molecule and then we will take a 5th and 6th question. And once the time is still there, then we'll take BCD option also. Other than that, otherwise we will take up it in the next lecture. Okay. So
Sure.
water molecule, we have already considered that water molecule is having this kind of shape where we know that only 2 atoms are there. So highest possible proper axis of symmetry would be C2. 2 atoms have to go 180 degrees. The 2 atoms are required. So C2 would be one axis, which is going along your oxygen. So if I'll take it as Z, X, and Y. So this is going along my oxygen, which is here, and H and H, they are going to like changing their position. So C2 along Z axis is there. One is there. Also, we know other than this proper axis, identity operator would always be there. Is it true? That 360 you will get identical. So that identity operator would always be there.
Yes, ma'am.
Now we need to find out whether there is any higher axis of symmetry. Is there any higher axis of symmetry possible? C3, C4?
No, ma'am, because only.
Yeah. So
I don't think so.
Even if you try to give like C4, so this water molecule, that H will come here and the other H will go there. So that we started with this one. And after C4, if we come like this one, so these two are not equivalent configurations, not at all identical. So C4 can't be applied, right? So C4 is not there, C3 is not there. Now we need to know how many sigma, whether plane of symmetry is there or not. So we have already defined the vertical planes would be one which would be containing the Z axis. We have taken the proper axis along Z. So one plane would be, this is my Z and this thumb is my Y axis. And here is one hydrogen, other hydrogen is there. I'm cutting it like this way. So though 2 hydrogens would be reflected by each other. So we have sigma YZ in the, that is stick, okay, it is present. Now what would be the other plane of symmetry?
Molecular plane.
Molecular plane, like you define molecular plane as what? X, Y or Z?
Perpendicular to your Z axis. I mean, perpendicular to your molecular axis, whatever
Right.
the C axis is.
See, when we will be taking here, the molecular plane is nothing but our XY. But the XY plane is going like this way and your molecule is above. It is not going to give you any reflection down. Whatever the reflection will come, it won't be an equivalent configuration. right? And if you're talking about the plane which is cutting oxygen, hydrogen, and hydrogen in equal halves, that is not at all a molecular plane because it is still containing the z-axis. So that molecule, this molecule we are defining, it is on zx plane. So this is my suppose z-axis, or this is my z-axis, the thumb is my z-axis, and this whole palm is my x-axis. So water molecule is on this way. And if I am having this yx plane, that will not cut my this into completely equal halves. That would give you a certain kind of reflection, which no other molecule is down. Like nothing is there to reflect there. So it is only having sigma zx, but there is no sigma xy. So sigma xy, which is perpendicular to your z-axis, that is called the molecular plane, and that is not present in your system. So only two vertical planes are there, one C2 axis is there, and one identity operator. Now you need to calculate all of them. As I told, that C2Z will give you how many operations?
Operation, sorry. One.
Right. So
one becomes orthogonal by identity.
This is 1, this is 2, this is 3 and 4. So the order of your water molecule will become 4.
Okay.
Is it fine? Like is it easy to calculate? And also you can calculate your point groups, which we might be taking in the next lecture. E plus
Okay.
C2Z plus sigma ZY.
It's C2V. It's
Yeah, it becomes a C2V point group. So that we define as H2 is having a C2V point group, and for C2V, the order of the molecule is 4. Similarly, you can calculate for HCl, cis peroxide, transperoxide. We will take up these examples later, but first we'll go through 5th and 6th question. Now we have this 5th question says, how will you differentiate between a facial and meridional isomers of Ml3X3 complex on the basis of their symmetry elements? So do you know what are facial and meridional isomers? They would be different isomers depending upon the position of your ligands. Right?
It's stereoisomers, I think. I'm not. Yeah. So I forgot.
I will just draw. So as we know that Ml3X3 would be having an octahedral symmetry, where I am placing all the L, like 3 ligands which are of same type at one triangle. The other one would be having another triangle. So we know that, right? This way it would form. This is one kind of triangle, and this one is another kind of triangle. Okay. Now the other one would be M. So there would be 2L over here, or 2L over this side. We are removing this L with your X. So X is there. Now this again would be L. So earlier they were like one after other, we can have a symmetry. They were making a triangle. Now they are not making a triangle over here. Yeah. So here. So if I'll consider this one, is this making a proper triangle? Triangle having all the three vertices having the similar atom. It is not making. So here it is making, right? So this is called, when we are having an adjacent over here, like L, and it is replaced by X now. This is called meridional based on the position. And this is called facial isomer. Now you need to define, on the basis of symmetry elements, how do we differentiate between these two? So facial would be having different kinds of elements, and meridional would be having different kinds of elements, or the point group. So what do you expect that facial is having? What is a maximum proper axis of symmetry that facial would be having? Is it C2? Is it C3? Is it C4? What would be the maximum thing? Hello? You can just try. Even if it is wrong, that is fine. So we are just, okay.
I think C2, because
C2
up and down.
But if I am having one triangle, one ligand, two ligand, this one triangle, we can consider it as a BF3 molecule. Boron is your metal. Yeah. So the other one is also BF3, but the boron is at the center. right? So right now might be a plainer picture you might not be able to visualize. If you go back and see these kind of facial isomers and their orientation, you will get to know that when I am passing through these two phases, which are the triangular faces, and I am passing the C3 axis, the 3L would be replaced by each other and the 3X would be replaced by each other. So they are rotating by their numbers, like they are only rotating by their. So C3 is there, right?
Yes, ma'am.
In here, in the metal which is meridional, if you will see that if I will take an axis which is passing through this L, M and X. So this L is reflected by, or the 180-degree rotation by the other adjacent one, the opposite one, and this X would be uh, replaced by the other X, which I have marked as double T. So C2 is there because whatever the C2 will pass through L, M and X, they are not going to change anything. They are just rotating like this way, but the other would be reflected by 180 degree.
Yes, ma'am.
Right? So this is containing maximum axis as C2. Corresponding to C2, there would be sigma planes also that you will get to know. If I will keep a plane along the same direction here.
Okay. It is not identical.
Yeah, it is not identical, but it is having an equivalent geometry. So my plane is existing here. So
Okay.
this plane is reflecting my one L to other L, the other X to this X. So that means plane is existing. So one, and this is also along my C2.
There are 3 C2s then actually, because along these X's, along these L also there is some.
How many the C2s?
I think around these two L's, the diagonal ones.
Okay,
And the long.
if we will, this would be coming like this way. If you will consider maybe talking about this picture, that is just not containing your L, M, and X. That would also contain your X also. Like half of the molecule would be there. Only two atoms would be there, which would be reflecting each other. So how do I explain? Like one plane which is containing above. This is your plane. L is above, X is down, M is there, and also I'm having this plane which is bisecting my X and X, and this plane also. It is containing the Z axis and this axis, right? And the only L and L, they are reflecting each other. Similarly, there would be one more plane along this Z axis, but now that is bisecting my L and L and reflecting my X and X. So there would be only two vertical planes. Why I'm calling it as vertical? Because that is along the z-axis. If you talk about the molecular plane, so all L, X and X are here, and one L is here, X is down, and I'm cutting it like this way. Now L is here and X is down. This is not reflecting each other. So no molecular plane exists, right? So C2 is there, 2 sigma V is there. So it would be having E, C2, 2 sigma V, that is C2V point group. Is it clear?
Yes, ma'am.
Similarly,
Similar like what?
C3, corresponding to your C3, there would be 3 sigmas. 3 sigma
Yes,
V would be there, which are reflecting. If I'll take one angle from here, which are reflecting other ones, or they would be along the planes of the triangles that would be having. So 3 sigma would existing. So C3 is there. Is there any C2 over here?
C2.
If I'll take along this axis, that won't be reflecting because other side is L, this side is X, this side is L, this side is X. So C2 is not there. So it is only having identity operator, C3 operator, and 3 sigma V. So therefore its point group is C3. Right? So facial is having C3V, whereas C2V is the meridional is having C2V. So based on the symmetry elements present, you can actually differentiate between the two isomers of a octahedral or any geometry for that matter.
Got it, ma'am.
Is that understood? Now, if I will ask you a similar kind of question over here, if I have this C3V and C2V, earlier we got to know how many operations are possible. What is the order of the C2V?
3. E C4, sorry.
Yeah.
E C2 and 4, 2 sigma planes.
So that is 4, right? What about then C3V?
C3V will have E, C3 and 3 sigma planes will be there.
Yeah. So 3 sigma V's were there. Now,
so 5 are.
Right now you will see that is 1, 2, and 3 sigma V. Now we know
So 5.
C3 would give you how many operations? Remember that
C3.
Cn will give you n-1 operation.
So 4.
No.
2, sorry.
Yeah. So that 2 would be C31, C32. So now count.
Yes, ma'am.
E plus C31 plus C32 plus 1 sigma, other sigma, third sigma. How many operations?
1,
6.
2, 3, 4, 6. Yes.
So now the order of your C3V becomes 6 and order of your C2V becomes 4. This is why number of symmetry operations becomes very important to calculate the order of your reaction. So any molecule which is having, just a second. So as you understand that why symmetry operations are very important, why I told you about the symmetry operations at the earlier, that this is where we calculate the order of our molecule. So any molecule which is having C2V symmetry or C3V symmetry, you will be knowing how many operations will be there. You do not have to mug up anything. C2V is going to give you 4 operations. C3V is going to give you 6 operations. If I talk about C4V, that would be 2 times. So that way also you can calculate whatever the number is there. In case of the C2V or C3V, that multiplied by the 2 factor. If it is C2V, that is 2 into 2. If it is C3V, 3 into 2, that is 6. If I'll talk about simply like C4V, what is the order of C4V? That would be 4 into 2, that is 8. So it is coming from the mathematics, but firstly, we need to understand how many operations are there. That is, there is nothing to mark up and there is nothing to, you have to just remember for that matter. Only when we have derived something, then we can come to the conclusion, okay, why Cn is going to give us n-1 operations, why C3V is giving 6 order, and why C4V is giving us 8 order. You should be knowing the explanation, but this is like a straightforward answer if you have to appear in any competitive exam and if you have derived all the equations by yourself. So is that clear?
Yes, ma'am.
Great. So we are taking up the last question. Then we will explain the other 3 examples that are being left. Now we need to define how many C3 symmetry operations are there in octahedral and tetrahedral point groups. We have an octahedral as well as tetrahedral point group. So again, a similar question, but in a different format it is coming. You need to find out how many C3 symmetry operations, total number of C3 symmetry operations you need to find out. So firstly, we'll take up the tetrahedral point group. So say for example, I've taken a case of methane. We know that methane exists in this tetrahedral format, right? How many C3s are there? Just along the axis. So first question, there are 4 hydrogens. Is C4 possible?
C4, right? C4, I think. C3 may not be possible.
C4 would be possible here. Okay, for example, that C4 goes through that. So this is actually in this particular format. 2 hydrogens would be in the plane, 2 would be above and below the plane. They're not like square planar. Square planar means everything is on the plane, this way. Here, 2 are above, 1 is above, 1 is down, and 2 are in the plane.
That much I can say.
Sorry?
There is a C2, I think.
C2 would be there, okay. Other than that, is there any high axis of symmetry? Just think about C3. So along, this is, if you consider, you know about the ammonia molecule. Ammonia molecule
Yes,
would be like this way. Hai na? So we
yes, ma'am.
say that C3 is going through N and all the hydrogens are going by 120 degree. Right? Similarly,
Okay.
here, if you will consider one CH bond, this is 1, 2, 3, and 4, and C3 along the CH1 bond. 1 is there, other 3 would be going around 120 degrees. Don't go with the
20.
bond angles of the tetrahedral. We are talking about the tetrahedral point group, not about the tetrahedral geometry or something like that right now. So all the 3 would be rotating by the 120 degree and you will get the equivalent orientation. Similarly, there would be one C3 along CH2, one C3 along CH3, and one along CH4. So therefore, how many C3s are there along each bond?
4 C3. 4
right?
C3s.
So 4 C3s are there. Now we know,
Yes, ma'am.
the 4 C3s are there. Number of C3s we found is 4. Now, how many operations one C3 will give?
1 C3 will give 3 minus 1, 2.
Right. So 2 operations would be there, which is C31 and C32.
Yes, ma'am.
So if one C3 is giving 2 operations, 4 C3 will give how many?
8.
Right. So therefore, 8 C3 operations are there in tetrahedral.
Okay.
So if you remember, maybe I can take
If
a
this
quick example.
axis means it's 4, but the operation means it's 8. That's
Yeah.
what it means.
Yeah. Only the 4 axes are there along the which we can talk about, okay, 4 C3 majors are there. But when we need to calculate, if I'll say tetrahedral point group is having order of 24, that means 24 element operations are there. So how the 24 is coming? It is comprising of 8 C3. So we have to calculate C31 also, C32 also. So in combination, we are talking about 8 C3. You understood?
Okay, ma'am.
So
Got
along
it.
the 4 bonds, we got 4 C3s. Each C3 will give you 2 times rotation, C31 and C32. That's why the total number of operations become 8 C3. So this is very important. These kind of questions, they do appear, and we don't realize that how to calculate how that 4 C3 is going to be 8 C3. Why are we not considering? Because that C31 and C32 won't be written separately. When we will be making a point group table, multiplication table, or a group table, at that point we just defined that C3 is there, and how many 2 would be there. It would be written as like 2 C3. That 2 C3 is like C31 and C32. That operation is there. How many C3s are there, that you have to multiply, and you will get a total number of C3 operations. If you'll go back and see how many elements are present in the tetrahedral, why the order of your tetrahedral point group becomes 24, there you will get to know it is 8 C3. Is it clear?
Okay. Got it, ma'am.
Okay. Now the next one was to find out in case of the octahedral. So in case of octahedral, we need to firstly see in octahedral, if I am having this kind of geometry. So there would be ligands. We are taking a case of ML6, which could be anything. M could be anything, L could be anything. And L, I have defined that it is having, the all are equal. That's why the highest symmetry, or the cubic symmetry, that we call as octahedral and your tetrahedral. We just saw no, the A equals to B equals to C. This is that case where the cubic symmetry is there. This is the highly symmetric, and all the sides are equal, right? Now in octahedral, we have how many vertices? 6. The faces are 8. The triangular faces I'm talking about. How many triangular faces would be there? That is 8. And edges, like each edge is like this one. If you calculate the edges of this one, how the octahedral will be formed, that is 12. Now, this I'm saying that there are 8 triangular faces. So we earlier saw, when I was taking the facial octahedral that isomer that I took, that if I took these kind of triangles, which I'm highlighting, so from these 2 triangles, in between that, one C3 would be there.
Yes, ma'am.
One C3 would be passing through the opposite triangles, and those triangles would be having 3 atoms, which would be rotating among themselves at 120 degree. Right?
Yes, ma'am.
You can try it by yourself also. Take 2 triangles, just rotate by 120 degree to one center, and both the triangles would be having like 120 degree with the equal orientation. So I said that there are 8 faces. So C3 is existing between 2 faces.
4. So 4 will be there.
So how many C3s would be there?
4 sets will be there.
4 C3. Again, how many operations 4 C3 will give?
8.
So the answer is 8. So in both the cases of tetrahedral as well as octahedral, we have 8 C3s. Total number of symmetry operations. If you need to define from where the C3 is going, that number is 4. That passing through the opposite triangular faces. But if I'll talk about the total number of symmetry operations, that is 8. So these two similar or minute descriptions we have to be very careful about. Okay. So is that
Okay,
clear?
ma'am.
maybe I can take up these tetrahedral and octahedral symmetry is also very important. So I might be explaining in more details how to analyze and how to see the vortices, how the triangular faces are passing. So if you want me to explain it more, just let me know. I will make one like half an hour we can take up for the tetrahedral and octahedral particularly because they are involving higher number of symmetry elements. Because of the higher symmetry, it is very difficult to define each and every element at any point. So if you need me to explain it in the next slide, next week session, I can do
Session.
that. Otherwise,
Yeah,
we can take the.
it'll be nice. It'll be
Okay.
nice if you explain it.
So we will take up the tetrahedral and octahedral, and besides that, whatever the week two lectures would be comprising of, we will take up in the next, and there would be some assignment problems. So these
Ma'am, is there any
questions,
textbook to follow for these kind of things? Any exercises? Any
uh,
what you anything common
particular
to?
book right now to I might have taken from the book only, but these questions that I make from myself, I like all the sources, so there is not one particular book. But for your purpose, I would recommend you something. Maybe in the next lecture I will define that whatever the reference book, you can go and try that, because there would be many complex books also. But for this matter, the main course is about circular dichroism and Mossbauer, so that is not about the group theory, right?
Okay.
So there would be
Okay.
one particular course on the group theory. So since the professor has started with the symmetry and you guys need to understand what is symmetry, so we are talking about the point groups of the symmetry. But maybe from the next 2 or 3 lectures onwards, there would be completely on the chirality, circular dichroism, how the techniques we have to use, or the MOSFET. Still, I would get you the references, whatever I have read for my particular lectures. Okay.
Sure, ma'am.
So the left part that we have left over here, we still have 10 more minutes left, so we can take up this HCl. So HCl is, we know that it is a linear molecule,
Yes, ma'am.
right? So this linear molecule, H would be there and Cl is there. Now, when I have a linear molecule, so say for example, I have defined this axis and what would be the maximum this N value? So
Only one.
no, like for example, if even if I don't rotate it, if I'll rotate it by there is 0 degrees because that is linear. So if
Yes,
I'm
ma'am.
just
It will be
rotating
safe.
it, yeah. So if I'm rotating just if this end of the point is H and this other end is my Cl, and if I'm rotating and rotating it by 0 degrees, there is no rotation, no, because this is along the axis, right?
Yes, ma'am.
So even if I tilt my angle, that would be 0 degrees only. I have to just move
Yes, ma'am.
the molecule in the whole. So if I'll divide 360 by 0, that would give me an infinity value. So C
Yes, ma'am.
infinity would be existing. When C infinity is existing, with that, we would be having infinite planes along the
Yes,
axis.
ma'am.
So there would be infinite sigma V's also. So this molecule is having C infinity point group. And when something is infinite, the order is always infinite. There's
Okay,
nothing
ma'am.
to calculate because we can't calculate how many would be there. There's an infinite number. How many
So you
want?
say if you have a CN axis, you will have N sigma V's
Yeah, yeah.
always.
It, no, I would say like there would be if you have gone through the lecture of the professor, that is something called when there is no rotational axis. So, for example, we have C1. C1 is nothing but a rotation of 360 degrees, so which we actually not rotating actually. So only after 360 degrees we are getting something, so that we call as a C1. If we have just a plane, that point, these are the point groups I'm talking about. This is not the axis of symmetry. Don't get confused with the axis of symmetry and the point groups. These are the point groups that we define. C1, CS. CS is nothing but when you have only one molecule plane, right? So this way it is going to give you the notation. And if you have that C1 would be like E only. It would be having only the identity. CS would be E and sigma. And CI would be having identity operation and inversion. Right? So these are the point groups. So which molecule which can't be having, like say for example a chiral molecule, it can only be having an identity, it can't be having any symmetry element, any symmetry element. That is why it is called as chiral. So that is why the point group becomes as a C1. If something is there which is only having a plane and identity, that is CS. So the question that you asked was that what was your question actually, that CN you were asking? Hello? May I know your question, please?
Ma'am, I was thinking if you have a CN axis, you will have n sigma v's.
It is not sometimes we can say that way, but there are certain examples where C2 axis is there, but no plane is existing. Because the plane has to give you a proper rotation. If one plane is there, the other plane has to be there. If I'm talking about the C2, so it should be, if it is having one sigma V, the second sigma V is supposed to be there. C2 will give you two sigma V, C3 will give you three sigma V. But if only the axis of rotation is there, but no plane is there, that is difficult because the plane has to reflect or to bisect something very equally. So there would be possible examples where only C2 is existing where no plane is there. But if C2 is coming with your two sigma V's, then it is fine. If it is not, then there is no case.
Okay, ma'am.
Yeah. So this is also done. Now we have, the question is, so we have cis H2O2 and trans H2O2. I will explain cis we have already seen. I was talking about this cis. So this cis H2O2, this is peroxide. Why we are calling it cis? Because both the hydrogens are at the same side, they are facing each other. So firstly, identity operator is okay, it is always there. Is there any axis of symmetry?
C2 will be there.
Yeah.
The middle
So
word.
to analyzing this molecule, if you consider both the oxygen molecules and combine together, that would be a case nothing but a water molecule.
Water.
Right? So
Yes.
this would be having a C2V point group. So C2 would be there, two sigmas would be there, and that would give you an order of 4. Whereas if I have a trans H2O2, trans means one H is down, other H is above. Right? Now identity is there.
Yes, ma'am.
Is there any inversion center?
Inversion center, I think it's there. Yes.
Yeah.
If you take O
If,
as
if
the
we'll
point,
go
it will go. You will reach
oxygen
hydrogen.
and oxygen. So you are going above H and H. So I is also there. Now, is there any C2 operation?
C2 in the trans, ma'am, or the fizz?
Yeah. So if you consider this molecule in XY plane, so if I have a rotation of C2Z, so do you think that 180-degree, this H will go here and this will come here?
Yes, ma'am, it will go. It should go.
So C2Z is there, right?
Yes, ma'am. Yes,
And
ma'am.
as we have already defined, the molecule is on XY plane. And if I cut that XY plane like this way, each atom would be cut by two halves. The bisecting
Yes,
would
ma'am.
be there. So there would be sigma H also.
Yes, ma'am.
Is there any vertical plane which is along the C2Z axis? That means sigma ZX is there or sigma YZ is there.
It is, there is sigma, there is one plane,
Which one?
mirror plane. This along the O bond.
If you will have the OO is here and H is on the transposition. If I am cutting like this way, do you think that your H and H is getting reflected? This H should come this way and this H should come this way. They are like trans, like this way. So they will not reflect it.
They will not. Okay.
Even if I will take up this one, so this C2 should be there. Like I have taken that axis along my Y or Z axis, right? So this way. So this Y is down and the other Y is above. This Y was supposed to be here. The mirror
Yes, ma'am.
has to reflect it like this way, right? So no
Yes, yes.
vertical plane is there, which is along the, so it is having C2H point group. So cis H2O2 is C2V, whereas trans H2O2 is C2H.
Okay, ma'am.
So you can define and find out. So all these examples, anyway, in 4 minutes, it is going to finish. Our lecture is going to end. So there is one more form, which is called open book.
Okay, ma'am.
H2O2. So you just check which point group it is belonging. It is belonging to which point group? Is it C2? Is it C2H? Is it C2V or anything like that? That is also second homework. And is there any question that you want to ask or any doubt is there? So far we have covered it.
Yeah, I just want to read up once. So about these things.
You
So
want
which is
to?
the better? I want to read up once because I heard the lectures also, sir's lectures.
Okay.
So I want to read up once. So I will see any book is there. I will start reading up.
Yeah, okay. So now maybe I will just note it down. In the next meeting, we will be discussing the tetrahedral, octahedral, and also I have to share the book references. You can also check the references that professor has provided. I don't know whether you have gone through that or not. Maybe I will give that references also. Okay. So references of
Okay.
books, and also to understand the symmetry very well, like point groups. There is one website which is named as Symmetry Autoview. So I will just write over here. So there is one. So there is something called Symmetry Otter Beam. So if you'll just Google it, you will get this site. There are a lot of examples, a lot of point groups where you can actually have the 3D rotation, plane or plane is there or something like that. I can just show you maybe one certain example over here. So this is Symmetry Autobeam. You just go to the website and here you go to the Symmetry Gallery. So if you'll see, there are a lot of point groups over here, right? So if I'm
Okay.
having this C1 CICS I was telling, so this is one example that would be giving you a 3D image. Okay.
Okay.
This is a 3D image where this one is your sulfur, this is oxygen, this is chlorine, and this is bromine, whatever the way you want. Now, if you will see, it is only having an identity operator. There is no operation. This is identity. If you will just click over here, it will not show you anything. There's no operation existing. If I will take up this, any other, for example, if I'm taking this water, as we have discussed water. So this is water molecule. This red one is your oxygen, this is hydrogen, and this is hydrogen. You can see down that C2V point group is there, and also the otter is also there. Here on the right side, if you will see C2 rotation, sigma XZ reflection, sigma YZ reflection, everything is there. Now, carefully see if you can able to see the video. So on C2, you saw that they are showing the rotation also. This
Rotation.
axis
Yes.
goes there. Similarly,
Yes.
sigma XZ, that is showing the reflection. Now sigma YZ, that sigma YZ is not coming like anything because it is just bisecting it. So it is just
Okay.
bisecting the molecule. So this is a very good site to have a kind of tutorial to understand the point groups and their symmetry elements very well. You can go back and practice this because this was what I started with. Like I was doing these molecules. So this will give you a lot of image that how the things work actually. So for example, if you can go for the octahedral thing. So octahedron would be like this way. So the octahedron, all the faces, the triangles are there. So you can see how many operations are there and what are the elements are there. C3, 8 are there. As I told you, na, that 8 C3s will be there. One C3 like this way, other C3 would be other way. So this way you can practice and see the orientation by yourself. There's nothing you can mugging up and you have to just analyze like in imagine everything. You can actually see on these websites.
Ma'am, this kind of tutorials happens Friday and Saturday or only on Saturdays?
I am taking this tutorial thing and the assignment thing on Saturdays from 7 to 9 p.m. For this particular course, there is one more TA allotted. I think her name is Tanu and she is taking the classes on Friday. So you can
Because yesterday I logged in, nobody was there. No, that's why I asked. Maybe there was no meeting.
Friday on Friday.
28th it was written. I got a link yesterday, the 28th, 6 p.m. I think. 7 p.m. Sorry, 7 to 9. So,
No,
but when
no.
I logged in,
I
meeting
think
was
that
not.
I think her slot is from 5 to 7 p.m. or 6 to 8 p.m. I can get it confirmed. My slot is from 7 to 9.
Okay.
You have to
So
join
there
by
are
7 only because before that we won't be able to switch on the video or something like that. So my classes is on Saturday 7 to 9 p.m. until and unless this course finishes off. And the second TA will be taking up on Friday. I will get the timing cross-checked by her. Maybe 5 to 7 is there, but you guys would be getting a link every single week. Like there would be a notification that they are going to have. So just read out the time properly. Like whether it is 7 to 9 or 6 to 8 because last time also a lot of people they are joining when the session is about to finish, so that is where we also don't feel how should we explain each and everything. Okay. So my
Okay,
class
ma'am.
is only on Saturday, 7 to 9 p.m. That is a fixed timing. So
Sure.
in case